Good morning, everyone. My name is Justin Sears, Product Marketing Manager at Hortonworks. It's my pleasure to host our 7-webinar series entitled Discover HDP 2.1, covering all the new capabilities for Enterprise Hadoop delivered in Hortonworks Data Platform version 2.1. Today's Apache Falcon for Data Governance in Hadoop is the third webinar in the series. If you missed either of the last 2 webinars, New Features for Security in Apache Knox, or Interactive SQL Query in Hadoop with Apache Hive, you can find those recordings and Q&As on our blog. I'll be your host today, and I'm joined by 2 Apache Falcon experts. Himanshu Bari is a Senior Product Manager at Hortonworks. He's responsible for Apache Falcon and Apache Storm in Hortonworks Data Platform. Venkatesh Seetharam is one of the original architects of Hadoop. He is now a committer and member of the PMC for Apache Falcon as well as Apache Knox. Here's today's agenda. We'll begin with why you need Apache Falcon. Then we'll cover key new Falcon features. We'll move to a demo, and we'll finish with time for Q&A. We've got 30 minutes, so we're going to move quickly. All attendee phone lines have been muted. If you have questions during the presentation, please send them to Himanshu Bari in WebEx chat. Venkatesh and Himanshu will take time to answer those at the end of the call. And if we don't have time to cover all those questions, we'll include a full Q&A in an upcoming blog post about this call. Let me set the stage for Himanshu and Venkatesh. This is a modern data architecture to store and process data from a wide variety of sources. Data comes in structured columnar formats and also newer, less structured formats like those found in human-generated content like Word documents or emails. Also in weblogs and clickstreams, social content like tweets, and in machine, sensor, and geolocation data. You see those data sources down at the bottom of this slide. Apache Hadoop works well in combination with familiar data repositories like RDBMS, EDW, and MPP to store and process a full spectrum of data. That data is then available to a variety of data access applications and BI tools to complete many different data workloads, such as batch processing, interactive query, stream analysis, NoSQL search, and others. Through our experience with more than 100 enterprise customers running HDP, we know that enterprises need 3 additional capabilities to be integrated with data management and data access. They need data governance and integration, the topic of today's call, and they also need security for the Hadoop cluster, and they need tools for cluster operations. You see those on the right. In today's webinar, we will focus on data governance and integration. We'll cover more components of Enterprise Hadoop in additional webinars over the next 5 weeks, and recordings of previous Discover HDP 2.1 webinars are already available on our blog. Now I'll turn it over to Himanshu Bari for the overview presentation, and then Venkatesh will do the demo. Please remember to send Himanshu any questions in chat. Let me pass control over to you, Himanshu.
We will talk about just the overview of Falcon, kind of understand why Falcon. Then I'll go through the features at a high level, and then we'll do a overview of the architecture and walk through a use case and demo of the use case led by Venkatesh. So the first question is, why Falcon? And as our customers look through putting Hadoop to production, the first step often they go after is, let's do a simple POC, where we're landing some amount of data in HDFS. We run various scripts, be it big scripts, your MapReduce jobs, or Hive queries. You clean the data, and then you get it into a prepped state where it is perhaps joined with other data from your data warehouse or relational database, and it's made available for your BI tools for visualization and querying and so on. As customers go through this simple POC, usually to get this simple pipeline running, it manifests itself as a relatively simple UZI workflow. And you can hand code this and put together a POC of this nature with relatively less effort. But what happens is that once you take this little pipeline and you want to put this in production, it results into addition of a whole lot of other typical data governance requirements, and the pipeline gets incredibly complicated. And it results into a lot of complicated oozy workflows that you have to hand code. And you also have to worry about orchestrating other tools like this CP that deal with replicating data from your pipeline to another Hadoop cluster or to your backup locations. And the reason why all these complications arise is, once you put this in production, there's typical data governance requirements that you have to worry about. So your data stewards are often going to have to deal with doing impact analysis of data once it lands into your Hadoop cluster. So you have a bunch of files in a certain HDFS directory. What happens if you move those files from one place to another, or you wanted to change those files? Who will get impacted by it, right? Which processes and scripts are going to have to change if you make some changes to those files in a certain HDFS directory? And they also want to be able to monitor that entire data processing pipeline end to end. So not just the infrastructure, but also the entire pipeline, the processing of the pipeline. The data stewards are going to want to be able to track ownership of that pipeline. So who created a certain process, what files they processed, and when that processing pipeline changed, and so on. And the last part is from a late data handling standpoint. Often when you deal with landing data into a certain location in the Hadoop cluster, it's not a one-time event. It's not like all your data is going to arrive at the top of the hour. Usually, given the variety of different sources you're generally aggregating data from, if you're looking to have a process that kicks off at, let's say, 10 o'clock, that process is probably going to have to deal with data that arrives until, let's say, 10:30, because it takes a little bit of time for all the data to arrive at that location. So how do you go about handling that? Then from an IT administrator standpoint, you got to be able to monitor the infrastructure. They will have requirements around replication of the data. And the replication requirements are often not just blanket requirements that, hey, just take everything in this Hadoop cluster and replicate it to some other backup cluster. They often land in a way where you want to have different replication policies for your cleansed data, different replication policies for your raw data. So how do you go about handling all of that? And then in the end, there is always compliance teams who will have requirements around audit and retention policies that they want to enforce on your data pipeline. So all these requirements end up complicating your simple data pipeline, and you needing the data steward or the person putting together that pipeline having to write a lot of manual workflows. And there's no easy way today to actually reuse any of this across different pipelines, or you really cannot have a certain template that you can simply put together. So that's exactly where Falcon comes into the picture. So what Falcon does is that it takes all of these data governance related requirements, and it provides features around being able to define a pipeline that has certain replication, retention, eviction, and late data policies attached to it. It allows you to monitor that pipeline end to end, and it allows you to trace that pipeline. And it automatically generates all the different oozy workflows by adding all these requirements to your pipeline. So and thus preventing the user from manually having to write these extra steps and add them to every single pipeline that they're dealing with. And it really incredibly simplifies that process. So let's go through the features in Apache Falcon real quick. So before I talk about the features, I want to introduce the basic concepts in Falcon. The first thing is cluster. A cluster is what you might intuitively think to mean, which is a Hadoop cluster. But the way it manifests in Falcon is that when you define a cluster, it typically is going to have a bunch of different interfaces into that cluster. So it will have links to your name node, to your oozy server, and so on. Then you have feeds or data sets, which refer to what you would think is your data. So they are called as feeds and data sets in Falcon. And then you have processes that run on the cluster, and these processes take these data sets as input and perhaps create more data sets as output, right? And all of these things put together form your data pipeline. So these are the basic concepts in Falcon that you would see us repeating as we go through this presentation and as you see the demo. So let's go over how you go about defining a data pipeline. So a data pipeline in Falcon is a bunch of different XML files that represent your clusters, feeds, and processes. Now you define these clusters, feeds, and processes in separate XML files that can be linked together, and they're intentionally designed to be that way, so the whole process can be modular. You can share processes between one pipeline to another because they are being defined separately, and you're just linking them as you're creating your pipeline. So it enables you to easily reuse your processes and data set definitions across pipelines. And then there are out-of-the-box policies for you to be able to specify what kind of replication requirements you have across the different steps of your pipeline, how long you want to retain data across the different steps in your pipeline, how do you want to handle late data handling. So all of these are just simple policies that are tags that you add to your XML definition of your processes and feeds, and specify things like time duration you want the data to be retained, or the location where you want data to be replicated. And then Falcon takes care of automatically generating the required scripts and UZI workflows that take care of manifesting and executing those requirements. And the last part is the whole pipeline definition itself is extremely extensible, because as the processing engine of your pipeline, you can tie a pick script, you can execute a Hive query, or you can actually just kick off another UZI workflow. And because of that, you can tie any sort of external transformations that you might want to add to your pipeline right in the pipeline definition. So we often see customers wanting to do things like encrypting the data as it goes through various stages of their pipeline. So you can easily tie an external encryption solution as one of the steps in your pipeline. So as an example of replication and retention, I have a simple pipeline here as it's going through various stages. And as you will often see is that the requirements to retain and replicate vary by different stages in this pipeline. So perhaps you might want to retain your raw data for a long period of time, but only replicate it locally. But for the final data set, that is the cleansed data set that is being enriched, you might want to retain just the latest copy. There is no need to probably retain all the different stages of the data, but you do want to replicate it to your backup cluster, right? So Falcon simplifies how you add these policies across the different stages of the pipeline, and you will see that soon in the demo that we show you guys. For the pipeline monitoring, the combination of Falcon and Ambari helps, where Ambari is going to take care of monitoring the Falcon server itself and the underlying Hadoop infrastructure, and then Falcon has built-in alerting mechanism where you can get alerts for when an instance of your pipeline starts, if it ends, if you suspend or resume it, or if there is some error. You also get the run history of the pipeline. So Falcon has a simple UI where you see a list of all the different instances of the pipeline, and then you can obviously schedule the pipeline to run at certain times. So you can specify start and end times of the pipeline. So you can do things like a certain pipeline runs only during off-peak hours on a given cluster. For the pipeline tracing, first thing is you can visualize dependencies between various components of your pipeline. So your pipeline might be dealing with various different types of data sets and different types of processes that process these data sets. So the Falcon UI has a little graphical representation of how all of these different components are linked together for your pipeline. And it really helps in addressing that use case of, let's say you want to do some changes to a certain step and you want to see who all is dependent on that. So you can do things like impact analysis based on that. Falcon also allows you to do data pipeline tagging. So you can add open-ended key value pairs to data sets and processes. So one of the most common data or tags that we see customers wanting to add is external source systems that the data is landing into your Hadoop cluster from, or external destinations that are going to consume the final prepped and enriched data from your Hadoop cluster. We also see people wanting to add tags around ownership of data or the business meaning of data. So all of this metadata can be easily captured in open-ended key value tags that you can add to your data sets and even to your processes. And then Falcon logs all the changes that you're doing to the pipeline in terms of the user and when they made changes to the pipeline. And we also have a lineage graph where that will show on every instance of your process, which input data set it used, which output data set it generated, and it has a visual view of the lineage. So now let's, at a high level, look at what the user flow is like when you are interacting with Falcon. So the first step for the user is to create all your the pipeline definition. So the pipeline definition has the XML specification for the cluster where the pipeline runs, the data sets that the pipeline uses, the processes that the pipeline has. And you define these XML files and you invoke the submit CLI command in Falcon. And as a result, the Falcon server is now going to validate all your definition to make sure that you are referencing things that are valid. And it saves all of these specifications in a config store in HDFS. The next step is you want to schedule the pipeline to run based upon your valid start and end time. So for that, you invoke the schedule command in the CLI. And this is a step where now Falcon then generates all the different Uzi workflows that are required to address the different replication, retention, and other policies that you added to your pipeline. And the last step is for you as a user for you to just then manage the pipeline. So you can do things like suspend, resume, kill your pipeline, and the various other commands on the CLI available for you to make to take management type actions on your pipeline. All right, so now let's briefly go through the architecture of Falcon at a high level, and I'll walk through a use case that Venkatesh will demo. So from an architecture standpoint, Falcon has a server, which is a stateless server. You can think of it as any other management server in the Hadoop ecosystem. This server provides that centralized orchestration framework that is going to save all the pipeline definitions. It also has an embedded JMS based on ActiveMQ that users can subscribe to get notifications, various types of notifications on your pipeline. And then the Falcon server takes care of dealing with the underlying Hadoop ecosystem components based upon your definition of your pipeline. And Ambari on the right acts as a common management framework for Falcon as well as the other Hadoop ecosystem components. So you can install and manage your Falcon server and monitor your Falcon server right through Ambari along with the other Hadoop ecosystem services that Ambari manages and monitors. So next, let's do a quick demo of the system. And before I do that, I'm going to walk you through a simple use case that we will be demoing. So, and this is a very real representation of the most typical use case that we see our customers come to us about Falcon, right? So what you have here is that you have clicks and impressions data that is landing hourly in your primary cluster in a certain HDFS location, which is based on date when the data is arriving. And your primary cluster is located in your Oregon data center, and the data that it's capturing is from all your Northwest production servers. Now, this input data feeds can be often late for up to 4 hours, given that you have hundreds of servers scattered across the Northwest region. It takes a little time for all the data to arrive in that HDFS location. What you need to do is you want to be able to enrich the clickstream data with the ad impression metadata. And the end goal being that you want to be able to do some better customer segmentation to see what types of customers responded to what types of ads. So while the clickstream has information on the click about what ad the customer clicked, you want to enrich that click data with the other metadata about the ad. That includes information like what the ad was about, what the graphic, what the product, or what service the ad was about. And that is really important for you to be able to then do the customer segmentation. The Hadoop cluster does not need the raw or enriched data after 3 months. So you should be able to, you should be retaining only the data in your primary cluster only for 3 months. But you have to back up all the enriched click data and store it for up to 3 years in your secondary backup cluster, which is located in your Virginia data center, right? So now I'm going to hand it over to Venkatesh, who will show a demo of how you capture all of this information into your Falcon pipeline and how you run that pipeline.
Hey guys, good morning. Thanks for joining us. Let me switch the gears here and let's look at a quick demo. I have a sandbox running, HDP sandbox running with all the Hadoop services, including Falcon. We shipped Falcon as part of 2.1, and you could download the sandbox, which has Falcon as well. And Falcon also comes with examples for entities for clusters, sample feeds, which generates data, and sample processes as well. Here we have just created a mock use case to go over this demo and to make it meaningful. All the services are started by default in the sandbox, and I have added some entities and scheduled them to save some time. We can make this available so that you could repeat it yourself. I've used a CLI. Falcon today does not have a UI to submit entities, which will come probably sometime end of this year. We have two clusters here, as we saw. The first one is in Virginia. It's called a primary cluster. Cluster essentially is abstracts all your endpoints of different services within a Hadoop ecosystem, right? And it's quite extensible as well. So we have some metadata tags that Himanshu spoke about. It's very simple name value pairs, but these metadata is captured and relationships are associated with different entities so that you could explore it at runtime. So here the class is production, owner is someone, right? And are you guys able to see this clearly? Okay. So there is different interfaces here. Read only, again, historically you could only copy data from a different version because of wire compatibility issues using HFTP. Now we have web HDFS as well. Write is the RPC endpoint for it's read and write endpoint for HDFS. So it could be RPC endpoint, which is HDFS, or it could be web HDFS as well. Execute is the RM in Hadoop 2 and job tracker in Hadoop 1. Workflow is the Uzi workflow by default that Falcon supports today, even though that's extensible. Registry is the Hive metastore or the catalog, which use Thrift here because WebHCat requires a lot of plumbing. And messaging here is something that we use for notifications, both user level notifications, and Falcon uses notifications to do certain housekeeping of data sets and processing. So we have embedded ActiveMQ, but if you are running a JMS compliant messaging within your enterprise, you could use that as well. And some housekeeping locations here, which Falcon uses. This is owned by Falcon, where it materializes, workflow definitions for Uzi, distributes libraries. You can use out-of-the-box services that Himanshu covered, like retention, replication, late data handling, things like that. We have, Java classes that we have written so that you don't have to rewrite them. You could just reuse them, and we ship all those jars for it to be used within the workflow execution. We have two clusters. One is the primary cluster, other one is the BCP cluster. BCP cluster is very similar, except that it's in a different colo. Again, logical, we don't verify the colos, but it's a logical separation here, right? And if you remember the use case he covered, it was this diagram here. So we have two processes here. One is an ingest process. You have to ingest some data from an external system here, right? I've modeled this as a process within Falcon just to see, give you the power of Falcon. So here, if you see, there is no input to this process. We call this an ingest process, which goes, has a very simple workflow, which goes SCPs some data from an external system. And here we have clickstream coming from, some web server logs, impressions coming from, some other web server logs, which could be aggregated, cleansed, or it could be raw, right? These are, this process creates, clicks ingest process creates clicks, and impressions ingest creates impressions. That means you have two feeds defined as outputs, right, for each of them, right? And we can go look at the definition here. We have processes here. It will tell you what's the status, whether it's running, submitted, things like that. So if you look at the clicks ingest process, I have some instances running. So here a process has a unique name. Similar metadata tags, you have owner, publisher, you can have, is it a secure process, it's, open-ended process, arbitrary tags, and what are the set of clusters that this process runs in, right? You could, have one or more clusters here. I have, this running on a primary cluster with some validity. You could have multiple clusters. That means you get hot processing capability, right? None of the other products in the Hadoop ecosystem could actually do hot processing for you. So if you have one process and you want to run it on multiple clusters, you just declare multiple clusters here declaratively, and Falcon will take care of orchestrating them and kicking off that process as soon as that data becomes available in that local cluster, right? You can do hot warm also. If you're doing replication, right, then once replication completes, this process triggers. So hot warm is again very simple if you have a replicated data, but if you have ingesting data hot, then this configuration becomes a hot processing as well. So there are some concurrency constructs here for your workflow scheduler. So if you have more than one instance of data becomes available, right, the feed that you have configured, do you want more than one instance of this process running? Here it's one. If you have more than one, what's the order? We support LIFO, FIFO, and last only. First in, first out, last in, first out, and last only. Last only means, ignore all the other instances, just process the last instance, right? So that means your process will take care of them cumulatively. So here, as we said, the output is essentially a clicks feed, which we're going to define, look at. And then what's the workflow? Workflow here is something that the user is writing. We don't interfere with what the user wants to do because he knows that best. And we don't reinvent any wheel here, right? So here, the engine is Uzi. We support multiple engines. We also support for data governance and lineage. We support, supporting or expressing, what's the name of the workflow, the version of the workflow. You can increment your versions, right? And we capture those versions for every process that ran. That means you can always trace back to which version of this workflow ran for this process, right? And engine, we support multiple engines, as Himanshu said. We currently support Uzi, Hive, and Pig. We are in the process of adding cascading and maybe Spring Batch in the eventual future. Path is where your workflow definition is, right? And we also support coarse-grained retry policies here. So you can have multiple policies, back off, exponential back off, periodic, with delay and number of attempts that you want to have. So this gives you a very nice way of expressing the user process declaratively, right? And, this is a dependency graph of, your process here generates clicks feed and runs on primary cluster here, right? Those relationships are not captured here, but in the lineage information, those relationships are captured. So let's, for, clarity, completeness, let's look at the feed definition that we use there, right? So we have a clicks feed that was the output of that process. We also have some tags here, right? You can have source is equal to, some warehouse, publisher, classification is secure. If you want to have multiple classification, you can repeat that. Classification equal to secure, comma, classification equal to finance or sensitive or what have you. We also support some, grouping a bunch of feeds that belong together logically into groups. And, this feed belongs to ETL and BI, right? And, periodicity of this feed, it's an hourly feed. You can have different time zones associated. Default is UTC. And again, here you can express different multiple clusters. So you can have different combinations of this. If we have something called a type here, type equal to source. If you have more than one cluster and you have one type, one source and one target, which I'm going to show there is an example, automatically Falcon, associates a life cycle of replication for this. And if you look at here, you can express your retention policy as 30 days and action is equal to delete, right? We support multiple actions. And this is a policy. You declaratively mention retention automatically. We schedule a workflow to retain your workflows. So this is, we support multiple storage. One is, file system storage, which is a location on HDFS. You can also have a Hive table, and you just specify the table and a URI. We support, notion of vacuoles, who the owner is, and the schema, right? And going back to data sets, for in the interest of time, very similar. This enrichment process is a join process, right? This does a join. There are multiple inputs here and one output. That means there is a join between impressions feed and clicks feed. And we're going to look at just the clicked enrichment feed, where we are doing a replication. So here your cluster is equal to source and cluster is equal to target. That means automatically we're replicating this data across the primary and BCP cluster. You can have multiple sources, one target. You can have one source, multiple targets. All sorts of combinations, and declaratively you get this ability. So let's look at the most complex join here and look at lineage here, right? The cool thing is, for completed workflows, you can click on logs and it takes you to the actual workflow definition that executed within OZ. And, it pretty much, looks like this here. All the workflows that are running here in OZ. OZ is a little slow. So let's come back to that with, looking at lineage here. So as we saw, this is the process that we ran, right? Clicked enrichment process. So here, the user workflow name that you had provided, the workflow engine, the publisher, it runs on the primary cluster owned by, Ambari QA is the one I submitted as, who is the owner, which was one of the tags, metadata tags. We capture all these relationships and you can do actually searches in the backend. Today, we don't expose that relationship searches in the front end, which we will soon. So you can say, give me all the data sets that are secure and owned by certain user, right? Things like that. So here, lineage also shows this is a terminal feed. That means this feed is not used by anyone else. So with a grade double circle is essentially a terminal feed. And if it has certain attributes. We display this. You double click on this one. You can go and say who actually generated this, right? So what is the source of this feed? So here we see clicks ingest feed, ingest process, and we saw it doesn't have any input feeds. It's a terminal. So here also, you look at who generated impressions feed. For this instance, it was this, and when you click on it, you get a bunch of attributes. So this essentially is lineage information per instance, and it's displayed on the browser today. And there's it's all captured in a graph database very neatly, and we expose REST APIs on the graph database as well. So you could do very interesting things there. So this is the job that ran the user pick job, which is the join. And you can look at, what were the steps in the workflow. We have some pre-processing here. We have some post-processing here that Falcon instruments. And you can look at job log. You can look at job tag as well. As I said, Uzi is a little slow, but you get the idea, right? So it gives you a higher layer of abstraction to work with without worrying about, writing Java code or writing Uzi APIs. And if you look at the job definition here, it's extremely complex for this, which is like hundreds of lines of XML. And if you look at Falcon XMLs, they're very, very small, few lines of, 10 to 15 lines of XML, very easy to deal with, and you don't have XML hell. So if you look at the Uzi workflow, it runs through pages and pages of things which are generated by Falcon, and takes care of nuances in Uzi, working with Uzi and things like that. Okay, I'll hand over to Himanshu for.
Thanks, Venkatesh. I think this was great. So we are a little over time, but I'm going to pause here for questions, Justin. So we did have a few questions come up in the chat window, and let me take a couple of them. So the first one was, is Falcon, what version of HDP is Falcon supported in? So we just recently released HDP 2.1, and Falcon is supported as part of HDP 2.1. The other question we had was, can you use the Falcon UI to define the entities and manage the Falcon pipelines? So today the Falcon UI is read-only. You cannot define the entities on the UI, but that's something that we are working on, and it should be available very soon. I think we're set, Justin. That's all we have for now.
Fantastic. So let's keep this slide up for a second. I want to thank you, Venkatesh and Himanshu, for taking the time to share your expertise around Apache Falcon and data governance and walking through that excellent and detailed demo. Thank you very much. And I also want to thank all of you attendees for joining today. If you haven't signed up for the remaining 4 Discover HDP 2.1 webinars, you can do that from hortonworks.com/webinars. And next Wednesday, May 28th at 9 a.m. Pacific time, we will hold the 4th webinar in the series, Apache Hadoop 2.40, Yarn, and HDFS. We hope you can join us for that next week. And this ends today's webinar. Thank you very much.